Good afternoon, my YouTube viewers. I'm going to be covering the last parametric test that you can do in Excel that I know of, and it's a Friedman test. And this test, it's more like it's a test of repeated measures. And so what we're going to do in this is we're going to test three different treatments. So you've got subject 1, 2, 3. You've got 3 subjects. And then you've got treatment A, which is 5, 6, 7. Treatment B, which is 3, 4, 5. And treatment C, which is 4, 5, 6. So we're going to rank A. So rank.avg B2, comma B2 to D2, 1. So that's going to be 3. You're going to rank A again, and that equals E2 and E3, and then you're going to sum it, and it's a total of 9. And then we're going to rank B equals rank.avg brackets C2, which is treatment B, and B2 to D2, and it's 1. Let me just check this. B2 to D2, and it's 1. And so that's going to be a rank of 1. And then you total it, and it's a sum of 3. Now we're going to rank C. So rank.avg brackets D2 and in comma B2 to D2 and then 1. So it's going to be 2. And then you copy that down, and the sum of that is 6. So now we do the Friedman test statistic. So this is we're going to do the Friedman statistic. So this is the formula for the Friedman statistic. And what I'll do is you can just pause the video and write the formula down if you like. And you've got the number of subjects, which is 3. So really, you could have said count A, B2, or A2 to A4, and that would have given you 3, and that would be more accurate. So equals COUNTA, A2, A4 should give you 3. And then chi-square critical value treatments is K. So you've got 3 treatments. And again, you could do equals SUM B1 D1. That should give you a 3 as well. That didn't work. B equals sum equals count A, sorry. That should give you a 3. So now we've got our chi-square critical value equals chi-square.inv.rt bracket 0.05. That's your alpha of 0.05. And J4, which is your degree of freedom, which is 2. So your alpha is 0.05, and that's your significance level. So you check your degree of freedom equals J3 minus 1 is 2. And then so really, strictly speaking, that's J1. So that's going to be J1. So it should give you the same thing. So rather than saying 0.05, because you might not know what 0.05 is, but your alpha is your significance level. So now what we're going to do is we're going to talk about our null hypothesis and our alternate hypothesis. So your null hypothesis is there is no significant difference between the treatments, and your alternate hypothesis, which can be expressed as either HA or H1, is there is a significant difference between the treatments. So your we haven't really got a p-value that I can see, but we're going to interpret it. And so if H2 is greater than H4, so H2 is 6 and H4 is 5.9, you're going to reject the null hypothesis. Otherwise, you're going to fail to reject the null hypothesis. And you can see that the Friedman statistic is just 0.01 degree higher than the chi-square test statistic. But since it is higher than the chi-square test statistic, then you have to reject the null hypothesis. So you can see that in this particular example, it's cutting it very finely because your Friedman statistic is 6 and your chi-square critical value is 5.99. So that's going to conclude this video, but before I conclude it, I want to show you the chart that I made. So this is a chart that I made to show you treatment A, treatment B, and treatment C. So you can see that treatment A is higher than treatment B and treatment C. So that's why the null hypothesis has been rejected. So that concludes this video. The next video will be about another statistical topic, and I hope that you decide to watch it.